Not many people like mole calculations, but try and follow these steps and it makes it much easier. CuCl₂, known, ratio, and unknown. So let's take a look at this question and see what it's asking us. A student wanted to make 11 grams of copper chloride, and they've given an equation for that. They've also given us all the relative atomic masses of the relevant elements here, and they've said calculate the mass of copper carbonate. The student should react with the dilute hydrochloric acid to make 11 grams of copper chloride. This is a calculating mass question. So first thing I tell all my students to do is note down what the known substance is and what the unknown substance is. The known is what you know the mass of. The unknown is what you're trying to find out. So here it quite clearly says we've got 11 grams of copper chloride. So let's label that on equation. 11 grams here. Our unknown, we want to calculate the mass of copper carbonate. Copper carbonate is the one that we have here. We're going to put a U there to say that it's the unknown, and we're going to put a K here to show that that's our known. Okay, so our first letter in CuCl₂ is K, and that stands for known. What we want is the moles of the known substance. So in other words, we want to find how many moles are there in 11 grams of our known substance, copper chloride. So what do we need to do here? We need to use our equation for moles. Moles is equal to mass over mR. So our mass here is 11 grams. That's given to us in the question, and we've labeled it in our equation. mR, we want the mR of copper chloride. So that's one copper, because it's Cu, and then Cl₂ means we've got two chlorines in there. So let's add up the ARs of one copper, which is 63.5, and two lots of chlorines. So that's 2 times 35.5. We can put that all in our calculator to give us the number of moles of copper chloride we have. And if you do that, you should get an answer of 0.0817, and you've got a few more numbers there. Keep that number in your calculator, don't round it. I've rounded it here in our working out, but in your calculator, keep that number as it is. Now, that's our K done. Let's move on to our R. Our R stands for ratio. What we want to do is write the ratio of our known to our unknown. Our known, which is our K, to our unknown, which is our U. So what you need to do there is look at the numbers in front of these. Copper chloride doesn't have a number in front. If a balanced equation doesn't have a number in front, it means it's just 1. Same with copper carbonate. It doesn't have a number in front. So that's also a number of 1. It's not like hydrochloric acid, which has a 2 in there. That would have a ratio of 2. But the copper chloride and the copper carbonate both don't have a number in front, so we just write a 1 in front of them, which tells us it's a ratio of 1 to 1. So our known to our unknown is a ratio of 1 to 1. So if we have 0.0817 moles of copper chloride, that means if it's a 1 to 1 ratio, we also have 0.0817 whatever that number is, we have that many moles of copper carbonate. So now we have the moles of copper carbonate. Remember what the question's asking us? The question's asking us for the mass of copper carbonate. We need to convert the moles into mass. How do we do that? We use that same equation, but rearrange it. So that's where our third step, U, comes in. U stands for unknown. So we want to find the mass of the unknown. We're going to rearrange this equation now to give us mass is equal to moles times mR. We've got our moles here already. Is that number that's already in your calculator? So there's 0.0817 ... times that by the mR. This time we want the mR of copper carbonate because we're working out the unknown, not the known. So that is Cu, C, and O3. So we're going to use this number here, Cu, C, and then 3 O's. So the mR of this is going to be 63.5 plus 12 plus 3 lots of 16. Now put that all into your calculator and you should get an answer of 10.1 grams.